Let's try to continue. We have been designed the inverter. The third part you have to design is solar charge controller. Okay, so the next one is solar charge controller. So coming to this solar charge controller, we want to fix the system voltage. Okay, so you can fix the system voltage as a 12 volt system or DC. How to fix the system voltage? 12 volt system or 24 volt system or 12 threes are 36 volt system or 12 fours are 48 volt system. Let us try to fix this system voltage as an 12 volt system. You may ask a straightforward answer, sir, why you are fixing? Here you can see here power rating is less than 1000 watts. If the power rating is less than 1000, I can say the system voltage is 12 volts. If the power rating is more than 1 kilowatt, I mean 1 kilowatt to 5 kilowatt, then you can select the system voltage as 24 into 2. How much? 24 into, sorry, 12 into 2. 24 volts you can select. If it is from 5 kilowatt to 10 kilowatt, then you can go with 36. If it's more than 10 kilowatt, then the system voltage is 48 volts. Like that, depending upon the wattage of the power rating, you can select your system voltage. As a thumb rule, I know that all the power rating are less than 1000 watts or less than 1 kilowatt. I'm going to select the system voltage as 12 volt system. Now I want to select this charge controller. So coming to this charge controller rating, so what is the power rating of the inverter? So inverter or charge controller or inbuilt. In inverter only what you have? Charge controller. Okay. So what is the power rating? I mean, what is the power rating of the inverter? 600 watts, and I'm going to select the system voltage as how much? 12 volts. So this is watts I want. Therefore, what is the system current or what is the current required by this charge controller is 600 watts divided by voltage. How much? 50 amperes. Now you should go to the market and you have to select an charge controller. Okay, so if you ask if you want an off grid inverter, they will ask what is the rating of the inverter? 600 watts. What is the system voltage of your inverter? 12 volts. And how much current it has to withstand is, I want a minimum current of 50 ampere. The maximum current it has to withstand is 50 amperes. For example, if you select an 100 amperes inverter, the size increases and cost also increases. It's a meaningless design. So you should ask the charge controller how to select. I want only the customer, as per the customer design, which inverter we have to select? 50 amperes inverter with this capacity. So now we selected, load is given, inverter we selected, as well as the charge controller we have been selected. Now to supply this much amount of load as per the given problem, we need to design the next component is nothing but the battery, and we have to select the ampere hour specification of the battery. So how to select? Okay, see here. So now let us assume that the battery is also having an efficiency of 93% as specified by the manufacturer. Now this much amount of energy has to be supplied by what? Here we no need to bother about the power now. Why? Because we are focused on battery. Battery has to supply. In battery, what is there? Ampere hour is concerned with energy storage. It's not like power storage. It's like an energy storage. Why? Because it is a factor of hours, or is an component which stores energy. So that's why you have to consider energy. This much amount of input energy we have to give to the inverter. So who has to give this input energy? That has to be given by the battery. Okay, so now we want to calculate the input energy to be supplied to the battery. So what is the output energy of the battery? What is the output energy of the battery? 3420. Are you able to understand? So the output of the battery is nothing but input of the inverter. Yes or no? Okay, so now based on this energy output, you have to calculate how much extra energy I have to supply through the battery. Okay, so therefore what is the relation we have to calculate all these things? Efficiency is equal to energy output divided by energy input. We want to calculate input. Efficiency is given energy output is given. Why energy output is given? Energy output of the battery is nothing but input to the inverter. Are you able to understand to what I am saying? So the output of the battery is nothing but input to the, why? Because they are connected in series, okay, and the input energy of the battery is nothing but the output of the solar panel. It's like cascade connection, I can say, or series connection. So now I want to calculate the input energy. Who has to supply this input energy? Input energy to be supplied by battery. So input energy is equal to, what is the output energy? 3420 watt hour divided by, what is the efficiency of the battery given? 0.93 percentage. Calculate this one. 3677. Okay, 0.41. I'm rounding this as a 3670 watt hour. 3076 watt hour is the energy to be supplied by the battery. But generally now we want to buy a battery. So if we go and ask with this specification, they will give you a battery. No, we want to ask the battery either in ampere hour specification or watt hour specification. Now what to do is, here you can see the rating. It is a product of, how to write down watt hour? Voltage, ampere, hour. But what is the creating a problem to me? Voltage is creating a problem. That's why we want to divide this energy by volts. So I'm writing the input energy, I'm going to divide with system voltage, okay, divided by system voltage into depth of discharge. Okay, so the depth of discharge of the battery, I'm taking 50 percentage. Sir, you may ask why you are taking the depth of discharge of a battery is 50 percentage. So generally the type of battery what we use for solar systems are C10 rated batteries, and they are designed to be discharged only 50% of its capacity. If you discharge more than 50%, the life of the battery is going to decrease. Okay, so in such a way only it is designed. So now from this rating, so that's why here, in order to express in ampere hour, what is creating a disturbance for me? Voltage. That's why I should divide with system voltage, and this is also like a drawback to the battery, which is nothing but depth of discharge. That's why I'm dividing with 50 percentage. 50 percentage means 0.5. So now you calculate this value. So 3670 volt ampere hour divided by, what the system voltage we selected? 12 volts. You see here 12 volt system into, what is the depth of discharge? 0.5. And you can take the number of autonomy days. Okay, autonomy days means cloudy days also, that you will do in solar also. So perform this value. So you can see this calculation, voltage will get cancelled out. 6 6 10 610 610. What are the ratings? Ampere hour. Yes or no? Ampere hour. Now what is the, this 610 is the AH rating of the system. Then how many batteries we need to purchase? So let us try to round it off, and I'm writing this as a 600 AH is the system AH. Now we need to, generally in the market, so let us take in the market, how many batteries are available? 150 AH battery with a system voltage of how much? 12 volts is available. Then how many batteries we have to connect? So the formula for this one is, so number of batteries in series connection into how much? Voltage of the, sorry, AH rating of the individual battery, that is equal to AH rating of the system. What is the system AH? We got 600 AH. So the 600 AH is the system capacity divided by, what is the individual AH? What is the battery we have in the market? Individual AH of a battery, single battery is how much? 150. Therefore, 150 divided by 600, how much? 4. How many number of batteries we require now? 4 number of batteries, and what is the rating of each battery? 150 Ah and 12 volts system. And how we have to connect them? How we have to connect them? Use the brain. You require 12 volt system. Therefore, we have to connect them only in parallel. In parallel only, what will happen? Current is added. Current is added. Therefore, 150 into 4. 150, I mean 150 Ah battery, 150 Ah battery, 150 Ah battery, 150 Ah battery. All the positives you have to join to one positive. All the negatives you have to join. Automatically this is one positive, one negative. Each battery is 150 Ah, 150 Ah, 150 Ah and 150 Ah. In a parallel connection, what is constant? Voltage is constant. That's what I am saying. What is the system voltage? If you do as per your design, if you connect in series, what will happen? The system voltage is enhanced to how much? 48 volt system. What is the system voltage? 12 volts. How we can connect? Meaningless design. So you have to keep the things very clearly. So we have to connect these batteries only in parallel connection. When you connect in parallel, the current gets added up automatically. This can supply how much Ah rated? 600 Ah rated. So this is how to design the system. So successfully, what is the rating of the battery we selected now? 600 Ah. How many batteries? 150 Ah batteries of how many number? 4 number. In which connection? Parallel connection. Now we have to give that connections. Let's try to do the one more module. So now inverter we designed with 600 VA and solar charge controller we designed with the required current, and we have been designed the battery. Next, what you have to design? Solar panel. Let's try to design the solar panel. So last design is nothing but solar PV panels. The same. So this is the what is the input energy required by the system? 670 volt ampere hour. Okay. So this is whatever you are having. Okay. So this we are going to find out the solar panel rating is. This is the input energy to be supplied by what? To be supplied by what? Output of the solar panel. Okay, so let us take the solar system, and this is giving an efficiency of some 93 percentage. So don't fix all the time 93. Depending upon the type of equipment you purchase from the market, it may change. Okay, so now the output energy you have to supply to the solar system is how much? 3670. Okay, now what is the efficiency formula? Efficiency is equal to output energy divided by input energy. Okay, or you can write down into 100, or directly you can express in percentage. So I want to calculate now what? So output energy, output of the solar panel is nothing but input of the inverter. Okay, so now this I can write down energy input is equal to energy output. What is the energy output of the solar panel? Input to the inverter. Are you able to understand the logic what I am concerned? The output of solar panel is input to the battery. The output of the battery is input to the charge controller. The output of the inverter is nothing but input to the load. They are connected in series. Yes or no? Series means what you will connect? The output, the negative terminal is connected to positive terminal. Next negative terminal is connected to positive, or you can say output of one terminal is connected to the input. Output of next terminal is connected to the input. We want to have an interrelation. Why? Because they are connected in series connection. Therefore, input is equal to E output divided by efficiency. What is energy output? 3630 volt ampere hour divided by efficiency is how much? 93 percentage. Here one problem is there. Solar panels are generally expressed in what? Watts, and this rating is nothing but peak. Watt peak we write down. Here it is watts, but here what we have? 6770 volt ampere hour. So here what is the problem? Hour. Generally in India or in Andhra Pradesh, we have the sunshine hours. Okay, we need to divide with sunshine hours. Sunshine hours. How many hours sunlight is available in your location? So we need to multiply with hours, or we need to divide with hours? I want the rating in watts, but what is the concept which is creating a disturbance to me? Hours. I have to divide or I have to multiply? I have to multiply or divide. To convert this watt hour to watts, I have to divide. That's why I'm writing divide with sunshine hours. So generally we can take sunshine hours as 5 hours, effective sunshine hours. Sir, only why 5 hours? Maximum will take from 9, 10, 11, 12, 1, 2 and maximum 3. After 4 we will not consider. In which seasons? Winter season. But summer we may consider. So generally on our average I am taking sunshine hours available is 5 hours. So you see here hour will get cancelled. Automatic this will be expressed in what? Watts. Write down. How much? 3670 divided by 0.93 and into 5. 7, 8, 9 watts. So I'm going to approximate this might for some 800 watts. Sir, why you are rounding with the figure? Generally, if you go to market, if you ask, I want a panel of 789 watts, no one will supply. So I'm going to round it for 800 watts. Okay. So how much energy has to be supplied by the solar panel is 800 watt panels. 800 watt is the system required. So now we'll try to draw the overall diagram. Okay. So here how many solar panels you require? So 800 watts I have to generate. What is the system voltage? 12 volt system. Now how to connect the solar panel? Let us assume I am having an 100 watt solar panel I bought. 100 watt solar panel means automatically the system voltage is how much? 12 volts. I want 100 watts. Then how I have to connect them? Series or parallel? Series or parallel? I have to connect them in parallel. Why? Because system voltage is how much? 12 volts. So solar panel 1, solar panel 2, solar panel 3, 4, 5, 6, 7, 8. Connect all the positives and connect all the negatives. Now when you connect all the positive 1, one negative, you connect that to the charge controller. So 100 into 8, how much? 800 watt, and they are connected in parallel. What is the system voltage? So system voltage is like something which will, solar panel system voltage also 12 volts, battery system voltage also 12 volts, charge control system voltage also 12 volts, inverter voltage also 12 volts, and type of load you can connect only also DC load. It's also 12 volt system. Complete system is how much voltage? 12 volts. It may be each parameter also should be 12. In such a way you have to design. Okay, so this is how the design of the parameters. Okay, so now we will try to draw the overall diagram in this next session. Try to complete this.